So what I want to do now is I want to talk about functions of multiple variables. And I'm going to do this by working through a few examples. The first example I want to work through is 6.1.1 bank balances. And the idea is that we want to look at the future value of an investment as a function of four variables. One is initial deposit, the second variable is years, the third variable is periods per year, and the fourth variable is annual rate. All right, so the first thing we need to do is go ahead and put in our initial deposit, then years, then PPY, which is short for periods per year, and annual rate. All right. And then we want this to be the future value. Okay. So then we're designing this Excel sheet so that we're doing this as future value being a function, but the problem actually tells us that we want to also look at when I deposit 1,000 for 10 years with 4 periods per year, because it's compounded, the interest is compounded quarterly. And so that's an important thing to recognize when we're dealing with interest rates is the when it says compounded annually, that's 1 period per year. Compounded quarterly, that's 4 periods per year. Monthly would be 12 periods per year, and so on and so forth. All right. And then our annual rate is 5%, and so then we put 0.05 in here. Okay. Now, what we want to do is we want to use our interest formula, which is again in your book. It's with this problem in 6.1.1 bank balances, and it is future amount equals the initial deposit. So equals our initial deposit times parentheses 1 plus parentheses the rate, which is our annual rate, divided by PPY. So we can take our annual rate divided by our PPY. We close that parentheses, okay? And then we're gonna take that to the power of, so we'll use our caret, and then we're gonna use parentheses again because it's going to be years times PPY. Okay, and so then we will, there was a mistake right there. So notice we didn't close both parentheses. The mistake that was made was I needed to close this parenthesis and I needed to close this parenthesis, okay? And I had only closed one of them, all right? So that's what I did. That's why I added another parenthesis right here. All right, so then we hit enter. And we end up with 1643.619. So the thing to notice is generally often for money, we only want 2 decimal places, but I'm going to leave it as it is because when financial institutions track investments, they'll often use partial pennies. And so I don't mind seeing that. Your book does round that to 2 decimal places though. All right. So that's our first example that we wanted to look at. And what's nice is now, say I wanted to change my investment. I wanted to say, well, what if I invested $900? How much would I end up with? Okay. Or if I instead wanted to invest for 12 years. All right. Notice changing each one of these things changes our function. And so now we can have this function of 4 variables that is very customizable depending on our situation. Okay. It's very useful. And so that's one reason why we like to do it as a function of multiple variables. All right. So let's look at building a table with two variables. I think that's the next thing that's useful. So we'll go to the next sheet, okay? And we're going to look at, this is example 6.1.3, all right? So for example 6.1.3, we're going to look at building a table, and we want to look at the present value of a single deposit, all right? And so the question asks us, I want to produce a table that shows how much I need to put in the bank to have $100,000 at some point in the future. I will assume that interest is compounded annually. I want interest rate and number of years to be treated as variables. And I want interest rate to range between 5 and 6%, and the length of time to range between 5 to 40 years. Okay, and so in this case, whereas the previous example we were looking at the future value was what our function was, in this case we're looking at the present value, okay? And so the book again gives an equation to find the present value. And so the idea of present value is just saying if 10 years from now I have $100,000 from this investment, how much money did I have to invest today to get that? Okay, it's basically saying how much money today is worth $100,000 in the future. All right, so we need a couple of things. We need to figure out, we're going to have rate and years, because remember we're making a table, okay? And actually, you know, let's do something real quick. Let's move that down one. Rate years. And what we're going to do is we're going to say this is what is going to be our columns, and this one will be our row, and the years will be our rows. And so we know our final amount is $100,000, right? And then we know our initial balance is the final amount divided by 1 plus the rate raised to the power of years. And so what we're going to do, because our rate starts at 5%, we'll go 0.05, 0.0551, and then we'll grab these and we'll fill until we get to 6%. All right, so there we got to 6%. That's great. And then we were told the length of time should go from 5 to 40 years. So go 5, 10, and again, we'll grab these like this and go down to 40, okay? And so then we want to put an equation in here with the proper dollar signs so that we can fill the entire table and completely cover the chart, and we don't have to enter in an equation again. All right, so we want to say this is equal to the future amount, but that number doesn't change, so we'll put a dollar sign in both locations, right? And that's going to be divided by parentheses 1 plus the rate, parentheses. Okay. Now the rate is always going to be in the second row, but the column changes, right? And so we'll put a $sign in front of the 2 for the rows. And then we're going to raise that to the power of the number of years. And for the years, its row changes, but its column doesn't. So we'll put a $sign here. Okay. So we can easily fill the whole chart. Okay. And this will tell us how much we have to invest in order to have, at each interest rate and length of investment, to have $100,000 at the end of our investment. All right, so as an example, if we were to have 5% interest and only keep the money in the bank for 15 years, we would have to invest $48,101.71 to have $100,000 at the end. Okay, and so that is the idea about how to create these charts. These charts are really where absolute versus relative references become very important. All right, I'll see you next time. Thank you very much. Okay, so now we're going to talk about graphing. So we take our previous problem. This might be set up a little bit differently than it was in the previous portion of the video, but notice the main change here is that we took, well, we had our annual rate and our years in this block here, and we moved them to our labels to these places. And that's because if they were here, it would affect the way Excel graphs and it would mess up our graph. So let's select the data that we want to graph. Okay. Then we go to Insert. All right. And then we click right here. And we can go down here and look at the different surfaces. So this is a wireframe, and then this is a 3D surface. They both have their advantages. I'm going to click the 3D surface first. Okay. And so then we kind of see a 3D surface of our problem. And again, we can also look at the wireframe. All right. So this is kind of one example of graphing. And again, we can change our chart title, we can change our labels, so on and so forth, just like we could with one-dimensional graphs. All right. So the next thing I want to do is work another example. Let's look at that real quick. Okay, so let's move on to the next example, change tabs. Okay, so this example is from problem 6.1.5 in your book. And so what we've done is we've set up our Excel here, and we have our data table. And we could, and in the example, they talk about using the same methods we used previously to make a wireframe or a 3D model. And what I want to do now, though, is use Wolfram Alpha. Okay. And so what we're going to do is we're going to look at our function here, right? And so we're going to take this function and we're going to input it into Wolfram Alpha, and we're going to let this variable go from 0 to 500 and let this variable go from 0 to 700. All right. So let me show you how you go about doing it. Okay, so the first thing I want to do to make this easy on myself is I want to grab this and I want to grab Wolfram Alpha here and have them up there together. Okay. And so now that I have them both here together, I can look at my function here and copy it over here. And we're going to say the quantity of gizmos is going to be X, and the quantity of widgets is going to be Y in Wolfram Alpha. All right, so let's go ahead and begin. Notice we have 10x minus x squared divided by 50. So let's go and put 10x minus x squared over 50 plus 20y minus y squared divided by 40. And just to make sure everything works out how we want, let's put some parentheses in here and in here. All right. And then we want to say graph, and our x is going to go from 0 to 500 less x less 500, 0 less y less 700. Okay, let's see, now we have, and let's put a width. There we go. Let's see if that fixes our problem here. All right, and so now you see we get a couple different graphs. So we have this one here, and we can just look at that. We can copy image. Bring that right there. Okay. Copy image. Bring that right there. And so now we have a contour and a graph, and we've brought them into our Excel. And we've done that relatively easily. All right. And so notice this is really a nice graph here. It kind of gives you a good vision. You get to see how things work with the function. All right. So I hope this has been instructional. Again, if you have any questions, ask your instructor and attend office hours. Thank you very much.